Hello, everyone. My name is Simon Rance, and I am the moderator of the Keysight webinar today. And I'd like to introduce to you Kareem Khalfan. Kareem is the Director of Solutions Engineering for Data and IP Management at Keysight. And today, Kareem is going to take us through some of the secrets to proper version control and how to seamlessly manage your data along with tool integration as well, while effectively collaborating across multiple teams and sites as well. And with that, I'll hand it over to you, Kareem. Take it away.
So I'd like to start by welcoming all of you to today's webinar session. And as Simon mentioned, we have a lot of important topics that we will be covering in this webinar. The agenda that, and the topics that we would like to cover is going to start with, version control. And that's the basis of any data management solution. Second, we'll focus on reuse and traceability. It's a trend that's continuing to expand into all types of design, and it's something that we are constantly seeing customers adopting as well. From there, we'll look into why storage is still a topic of discussion. And fourth, we'll look into collaboration within teams members, within the teams itself, and of course, across the sites that may be working on a given project. And lastly, the benefits of having an integration that's seamlessly available within the design tools. The webinar, of course, it's a shortened time. It's about 30 minutes, so we'll definitely go into the highlights about these topics and into some details as well. But these topics are important because they help us strengthen the IC design flows. And once we have a strengthened IC design flow, we're able to address the challenges that projects and project teams may be having. So let's start by looking at the version control concerns. And we'll start by looking at what are some of the issues, requirements that version control systems need to address as well. So the first one is, we all know that working on the latest revisions may not be the best revisions to work off of. So we need to be able to hand off data using some of these labels. We also know that in certain types of designs, there are multiple users working on the same object. So resolving conflicts is going to be an important function as well. Data is getting bigger and there are more teams and users that are involved. So we need to provide security on the data that is getting managed and not rely much on the operating system as a way of protecting that data. Now, with many revisions being maintained, we need a way to easily go back and look at previous history, previous revisions that are in the repository as well. And lastly, as project managers would need to capture milestones, we need a way for the version control tool to also address this issue, which is capturing the milestones of the project. Now, when many customers look at version control, they focus in on the basic functions of version controls. They look at, does the tool provide a way for me to do my check-ins or commits into the repository? They look at ways of how the populate works and bringing the data into the user's workspace. And some tools may call this a checkout process as well. How does the update work? Is it only getting me the latest revisions of the data from the repository? Assigning tags or labels to the revisions so we can pass the data along to different team members or different teams that are working on the project. Having various interfaces, accessing the version control system, is it going to be through a UI? Is there a command line? So these are, again, various entry points to the tool. And lastly, how does the tool access or handle my access controls to the data as well? So these are some of the basic functions that customers look for. Now, within these functions, as I have seen over time, is that they're looking for more advanced capabilities. So when we look at the function of check-ins and commits, customers are trying to see if there is a way for them to work on branches. Branches basically give customers and projects the ability to work in a parallel line of development without affecting the main line of development. So if there's any experiments that they like to do or any variations to the designs, they would typically do those on a branch. Now, once you work on a branch and you need to bring that code back into the main line, there needs to be a way to merge it back in as well. So at this point, customers are looking for how is these conflicts and merging resolved? Is it automated? Is it doing it across projects and objects? And how much intervention is needed when we're trying to merge in these conflicts? And also, they're trying to implement workflows as check-ins take place, which basically means, an example would be, can I run a lint checker on my Verilog file as I check in? So this way I don't have to manually run the lint checker. It's automated within the tool. And this ensures that, the file that's getting checked in is properly vetted and, is syntax free. So it basically implements these workflows across the project for the check-ins that are happening on these certain objects as well. So check-in is no longer just putting it in the repository. There may be advanced capabilities that are needed when you do your check-ins as well. When you look at populating or bringing the data into the workspace, you need to look at it from different perspectives, which may be that is there specific content that you want to bring in. The project may consist of a lot of data, analog data, RF data, digital data. So based on the work that I'm working on and based on the permission, is it going to get me the right content? Different teams may have different styles of working. Some teams may want files and objects in their work area that are always writable, so they don't have to specifically do a checkout command and make changes to it. They can simply edit these objects and start working on them and then proceed with checking them in. So a tool needs to be able to handle these different type of working styles as well. When you do an update, can you update a specific object? Again, a project may contain a lot of content, and I want to keep everything the way it is, but maybe a certain library needs to get updated only. So it's based on an object or a directory that I'm interested in. And is it able to go back in time and recover the data? So if I need to go back to something that took place 2 weeks ago, can I just enter in the time and the date, and will it go ahead and recover that data for me? And also the ability to do updates based on labels. So I may be looking for the golden revision or release 1.0. So the ability to go back and retrieve data based on labels. And sometimes customers are looking for the ability to combine time and labels together and retrieve data. Now, assigning tags and labels is, again, very important, but there are different applications to these labels. So customers may be looking for, is it going to apply labels while I'm doing my design work so I can hand off my data to the next group? Is it going to give me the ability to capture the milestones of the project? And at the same time, we consider branches as being labels as well. So is it managing all the different branches that I have within the project? I may have a high-speed branch. I may have a low-power branch. I may have a bug-fixing branch. So these are various branches. And so we need the ability to maintain that list of labels as well. When you look at the interface, there should be multiple entry points, access points for the engineers. So having a standalone UI gives the ability for users to quickly and engineers to navigate through what the project structure looks like and kind of zone in into the directories that they're interested in. But having a command line interface gives them a lot of flexibility as well, because this way they can incorporate these commands into certain workflow scripts that they have. So DM is integrated into their design flows as well. But customers are also looking for integrations to editing tools that they may be using. For example, if I'm using VI or Emacs, maybe I want to do my check-ins and checkouts directly from the editor and not having to go back to the DM tool to run these commands. If I'm working inside a design tool for my schematic and layout capturing, are these functionalities available for me to access from the design tools? So again, the various access points are important to look for as well. And of course, access controls. Um, Many companies are implementing access controls because they want to protect the data that they have in these projects, and they're done basically for compliance reasons. There may be ITAR compliance or um, other export compliances that they may have to meet. So protecting that data, ensuring that it's being shared properly within the team is crucial. And this way, once the access controls are embedded into the version control system, you don't have to rely so much on the IT and the operating system support to make this work. So again, when we look at these functions from a version control standpoint, it's not just a simple check-in, populate, update, tagging, interface, or access controls. We're actually diving deeper into these functions because customers and the design flows require um, kind of these advanced capabilities as well. Now, as we all know, that chip design is getting complex. It is no longer just a single team that works on it. And of course, we know it's not a single individual that works on it as well. So the complexity in chip level designs are there. You have CPU subsystems, you may have a GPU there, you may have components and in peripherals that you may be connecting to. So there's a lot of various blocks that are needed in the chip design. And these components, these blocks may be sourced in through internal projects that you may have. They may be purchased from certain vendors that work on these blocks as well. So there's a lot more leveraging of IPs that we see in today's design projects. So at this point, once we understand that we're going to be using a lot more IPs in our design project, well, IP traceability becomes very crucial and is basically um, a component of reusing the data. So we have to look into the aspect that there may be third-party IPs, there may be in-house IPs that we're using in the project. We have to then keep track of the bill of material that belongs to that project. And this is something that we need to maintain across the entire project and even after the tape out's been done, because there may be certain industries that need it for auditing purposes. So if you're in automotive or if you're in defense and aerospace, the audit capabilities are definitely required to be there. If I am the IP developer, whether it's an internal IP developer, I should be able to see who all the consumers of my IP are. And at the same time, the consumer of the IP needs to be alerted if there's any new revisions or upgrades that are needed to that IP as well. So it's not one-way communication between the developer and consumer, it's bi-directional. And of course, if there are third-party IPs that are involved, then legal and licensing information, documentation needs to be captured as well. So again, looking at reuse, it's not just the ability to reuse that data, it's also the ability to trace where the IP is getting used. Now, Keysight's design data management solution helps with this process, and we'll first look at how the reuse challenge is being met. Again, when we look at the chip design, it's not there are many components that are involved. So if I'm working on an SoC type of design, I may have certain building blocks that are needed. There may be a network code that's being developed in India. There is a core that's being developed in UK, and I may have a baseband that I'm pulling in from Japan. And at the same time, I have some IPs that I need access to from Austin as well. So as the developer or the engineer on the SOC, I can come into that project, into my data management tool, and say, get me version 1 or release 1 of the network, get me release 5 of the core, get me the latest version of the baseband and the IPs. And this way, all of the data that I need for the project, for my SOC, comes together at the top level project that's being worked on in San Jose. So looking at the chip, I'm kind of partitioning it out into various components that I need to connect to and reuse. And this way, the SOS tool or the data management tool is able to help me build the blocks together as well. Now, having and looking at these components as independent components, there's a lot more reuse that can happen. Since the baseband is an independent project and the core is an independent project, we may have other projects using different versions of these components. So again, we're reusing this data, but we're also promoting the aspect of reusing all of this data as well. So now that we've established how reuse works, we also need to zone in into how traceability works with the Keysight's data management solution. If you look at the screenshot that's there on the right side, you'll notice that this is a consumer traceability report for a certain project IP. And this actually tells me where that IP is being used, which projects are using that particular IP. We can see what release of the IP is getting utilized. And we can also see if it's been used in a design project tapeout as well. So, this is a report that's very important to the IP developer because they're able to actually trace it and see which projects they may have to work with in case they find any issues with it. The next report in traceability that's important as well is that sometimes these references that you have, these components that you're reusing, may be referencing and leveraging off of other sub-block IPs as well. So you may have a design where two IPs are being reused, but they're both using the same sub-block component. The problem here is that they're using different versions of the sub-block component. So this now becomes important because there could be potential conflicts. In this example that you see on the right side, we're using the Autobot in the I2C and the SPI, but we're using different revisions of it. So again, the tool, the data management tool, has the ability to detect these conflicts and alert the project team of these conflicts, and then they can decide if it's okay to continue and move forward, or do they need to use a different version of the IP. And lastly, because we're keeping track of these transactions, generating various reports when it comes to looking at the BOM, the bill of material reports, looking at who the consumers of those IPs are, looking at when updates to the IPs were done and who consumed which version of the IP. It's very easy for us to go back and generate any traceability audit reports that are required for the project. So again, you can see that we're not just solving a problem of reusing the component, we're also providing the capability of tracing the various usage of the IP as well. Now, we all know that designs are getting bigger, they're not getting smaller. The actual chip size may get smaller, but the data that we're packing onto these chips are getting much larger. And various design types may have different data types, different objects that they're maintaining. So when you look at a mixed signal optical sensor, you can see that we may be managing close to 100,000 files, and the data size may be around 250 gigs. When you look at PDKs, we're looking at 300,000 files with the data size of 800 gigs. When you're looking at companies that are working on processors, it's close to 500,000 files, sometimes even more, and the data size tends to be about 1.5 terabytes of data. So the trend is not slowing down. The lower the technology nodes, the higher the consumption of disk space and the increase in the data objects that we're managing as well. So when you look at traditional approaches in solving or managing that data, a lot of the traditional data management tools that are available, some of them are freely available for download. The way they solve this is by having physical copies of the data in the user's working directory. So if I have a project that is 100 gigs of design data and I have 5 engineers working on it, it's going to occupy roughly, it's going to occupy roughly half a terabyte of disk space because I need to have all of these work areas and I need the users to have access to all of this work area project data as well. So, with more users getting added to the project, you can see that the disk space allocation increases, and you would, definitely need a lot more network storage as well. So this just multiplies with more projects and more users working on that project. So the way the Keysight's data management solution addresses this challenge is that we have work area models that have the same kind of flexibility as a local copy work area, but instead of having physical files in the work area, we're taking advantage of symlinks. So this way, the objects are there in the user's work area, but they are symbolically linking to a read-only version that they need access to. This is a model that a lot of our customers use. It helps them save a lot of disk space, and it also, at the same time, gives users access to the project content without having them sacrifice on the data that needs to show up in these work areas. So this is, again, something that a lot of our customers use because it, again, helps them save a lot of disk space for their work areas and project data. Now we've taken this a step further. We actually have another function that's available in our tool, which is called sparse populate. We know that reuse is something that is happening more and more, and a lot of the data that is getting reused and reutilized are IP data that is going to be there for read-only purpose. It's not something that the users will end up modifying. So why should we have all of that IP data show up in these work areas, even as links? So what we now do is we're able to create links at the IP directory level, and this actually dramatically reduces the footprint of the work area as well, and it creates these working directories a lot quicker for the users that are connecting to that project. So we have, of course, gone from having physical copies of the files to having symbolic links into these work areas, saving disk space, and taken it one step further by providing links at the directory level and the IP directory level instead of these individual files. How does all of this tie in together? How does this all work together? So I thought I'd kind of bring up this architectural slide to showcase this. So as you can see, the SOS, so the data management system from Keysight, has a way, has a cache daemon that runs. It manages our cache location where we're storing all this data. And users can set up their work areas as local copies. Sometimes that is a model that engineers would like to adopt and have physical files there. And sometimes, most engineers would prefer using the symbolic links to cache work area. In a links to cache work area, of course, the revision that the user wants to point to will be symbolically linked to this cache path, which is a read-only location. So at this point, this user is looking at revision 37. And of course, they can toggle between various revisions if they need to. So the flexibility is there as if it was a local copy work area. Now with the sparse populate, what happens is you would have the IP content there, and you would have various releases of the IP content in the cache location. And this way, both of these work areas, regardless if it's local copies or links to cache, will have a symbolic link pointing to the IP release 1 that they need for their project as well. So this is taking advantage of the best of both. While some work areas are having links to cache model, the IPs that are getting reused in the projects are still symbolically linked, but at the directory level. And if there was a new release of the IP, the link would be updated to the R2 release of that IP. And we can go a lot more detailed into this, but you can kind of get the idea that you're taking advantage of symbolic links to help reduce that project footprint on the disk side. Now, when you look at flows and collaborations with different design teams, um, it's a problem that needs to also be addressed, because without a proper flow, without a proper collaboration system, sharing all of this data gets very difficult. So typically the issues that you would run into is that you may end up working on the wrong revision of the data. You should be looking at revision 5, but you are looking at revision 6, and now you're working off of a revision that hasn't been vetted or hasn't been verified yet. So again, that causes issues because you don't have the right data set to work off of. With that case, you end up spending more time determining what is the golden revision, what is the golden data set that you need in your work areas. So again, it's a problem that if you don't have the right methodology and flow, you're going to spend a lot more time investigating what should be the right revisions. The projects that you work on, they need to record milestones. We need to capture what is the data and the data set that we have taped out with. So recording milestones is an issue as well if you don't have the right methodology there. If you have remote sites, then the data that you may be looking at the other site may be out of sync. And therefore, again, you're looking at stale data. So you may not be looking at the latest data set that's available. You may be working off of data that hasn't been synchronized over to that remote site. And of course, when you look at handing off the data, so you may have a circuit design team in the US, but your layout team may be in Bangalore, and therefore, handing the data off across these sites becomes a bigger problem to solve. So these are some of the challenges that we see project teams facing if they don't have a proper flow and a methodology incorporated. So let's start by looking at a flow. And this is just an example so we can highlight some of these features that the data management solution can help us with. We want to have a flow where we're able to promote the data from one group of engineers to the next set of engineers. So when you look at a digital flow, you may be working on RTL, you've completed your verification, and you need to pass it over to the synthesis side. So you may tag it saying that this object is now related to synthesis. And therefore, you work on your synthesis, and once the gate level simulations are done, you may need to pass it over to the physical design team. So you may label them the objects here and the revisions here saying release to PNR. And of course, once the place and route is done, at this point, you may say, okay, well, this is ready from tape out. So let me pass it over to the project management team. And you may label all of this content as saying release to tape out. Now, the analog team may have their own flow of passing the data along, but at the end, when they're ready to tape out, they may label everything as saying layout done. This way, the tape out work area, the one that the project lead or the project manager will be working on, will look for these two labels to build the content that is needed. And once the objects are there, they may run their final reviews. And once it's ready for a release or a tape out, they may take a snapshot saying all of this data equals my release 1.0 or tape out 1.0 label. So as you can see, we've used two types of labels. The first one as tags, which are dynamic, and they help us pass the data and promote the data to the next engineer. And then we've taken advantage of snapshots, which help us capture the milestone of that project. And this way, anybody in the project can always go back in time and build their work area based off of release 1.0. They don't have to keep track of all of this data or export it out in different directories to manage what is the tape out data. It's all maintained in the data management tool. And this way, they're able to always go back to any previous labels and build these work areas up again. Now, focusing and looking at the mixed signal, or sorry, the analog design flow, which can be extended into the RF design flow as well, is that they work off of different data sets. They may have schematic engineers and design engineers that look at the schematic objects, and they may say, okay, well, version 4 of the schematic has been completed, so let me go ahead and assign the design done label to this. At this point, the layout team or the layout engineer would look for this label, the design done label, and build their work areas. And they would then start working on the layouts, and maybe version 2 of the layout is completed. So they will assign the layout done tag to that revision. So we have properly handed that data over to the next team. However, there is a little bit more complexity that's required here, a little bit more fine tuning. So at the time when we see the layout done tag, we also need to apply that tag to the corresponding schematic. And taking advantage of the triggers, the automated workflows, we're able to assign the appropriate labels to both the objects, the layout done and the schematic objects. And this way we have a relationship that's maintained with that single tag between both the schematic version 4 and the layout revision 2. So the layout done tag is our final label that gets applied in this flow, but it helps us correspond the two objects together. So again, using tags, using labels will help us with a flow. It will help us establish relationships that need to belong for certain objects so that they're all tied together. So now that we have a design flow implemented, we have a methodology of handing off the data, it wouldn't matter where the engineer is located. Be in US, they could be in Bangalore, they could be in Israel, in Munich, in China. The flow is exactly the same for these engineers to follow. And so, the question of how we promote the data has already been addressed. Now the issue comes in is that, well, how do I share this data across the sites? So that's another challenge or a problem that needs to get addressed. And this is how the data management tool from Keysight addresses this, is that there is, from an architectural standpoint, you will have a primary server that's running at a primary site, and this manages your repository. So that's where all the revisions are kept. That's where all the metadata information is stored as well. And once you have a remote site, you will set up a cache system there, and the cache will basically have X number of revisions, and it will also set up how frequently the cache updates as well. So there's benefits to having a system that's automatically doing this for you. You don't have to set up manual rsyncing process. You don't have to set up FTPs between the sites to transfer the data back and forth. This is all done within the design data management tool. And again, the synchronization can be based on time intervals as well. Now, once the data is there at the remote site, the benefit for the user is that the users that are working at the remote site, they have faster access to that data. When they do their updates, it's almost as instant as working at the primary site because all of that data is readily available. It also reduces the traffic that keeps going back to the primary location. Because the cache is intelligent in this case, it has this metadata being synchronized over. If the user says, show me the history of the schematic or show me the history of a particular object, it doesn't have to send that traffic to the primary side and wait for the response. It can calculate that information locally, and the response time for these queries is a lot quicker for the users as well. And we know a lot of customers are taking advantage of utilizing cloud to help manage certain workloads there. Maybe they may have design teams that are running on the cloud doing design work. They may also have simulations and so forth that are being offshooted to the cloud. So we know cloud is important to the infrastructure for many companies. And I think most companies do use the cloud in some form or the other. So using the caching technology, we can push data over to the cloud. It's as if it's a remote site for the project. This way, the data is readily available on the cloud. You can run your workload, and once the workload is completed, you may want to push some data back to the project, so you'll be able to check in and push that data back to the project, or maybe even take labels and tags saying, okay, this has been verified. So, with the caching system, it doesn't matter if it's a remote design center or if it's a cloud environment, the system is able to handle both. And of course, there are many, many more benefits to having a system that is built in and as far as managing your remote site locations. Now, how we interface to various design tools and editors, it kind of helps improve the engineer's productivity. And at the same time, it gives them, more willingness to incorporate data management into their design flows as well. So this is, again, a very key strength for the Keysight's SOS system, because we actually partnered with multiple vendors here. We have customers that use various flows to do their design work, and these partnerships are very important because they help us integrate our data management system into their design tools and design flows. So in this case, we have integrations with the MATLAB tool from MathWorks. We have integrations with the Siemens Pixus and Tanner tools, with Synopsys Custom Compiler and Optocompiler. Keysight also has an RF design tool for schematics and layouts. So there is a plugin to that tool as well. We have many customers using the Virtuoso platform. So there are integrations inside the library manager, and of course, integrations with Silvaco and Empyrean. Now, why are these partnerships so important? Because we have seen companies use multiple tools across these vendors. So having one data management tool that can talk to these various applications is important. So this way, the data management tool and the version control tool does not change. And we have also seen companies acquire other companies that may be using different flows. So again, having a single data management tool is crucial for how the projects are getting managed as well. We also want to make sure that not only is the partnership strong with these vendors, but also that the system works across multiple operating systems. So working on Windows and Linux or using the web interface to manage objects is important. Having a UI to browse through the project structure and manage the IPs that are getting reused is important as well, and providing that command line. So flexibility of how you can integrate it into your existing workflow scripts that you may have. So hopefully you can see that we have these very extensive partnerships across these multiple vendors. These are just some screenshots I wanted to bring up just to show you an idea of how the integration looks like. You can see that we have statuses built into the ADS tool. You can see that it's directly interfaced into the design tools, and it's also knows about any automatic checkouts that needs to happen or check-ins that need to be prompted as well. The same goes with our extension into the Virtuoso Studio environment and the Virtuoso platform. It's all embedded into the menus, the design manager menu inside the library manager. And you can work on the selections of the objects, or you can even work on the hierarchy of the designs and do any version control or DM operations on those as well. And of course, it's also integrated with the custom compiler. And you can see here that the menus are also extended into the editors. So if you're in the schematic editor or the layout editor, you'll be able to stay within those editors and do your operations. The integrations are important because this way the users don't have to toggle between these various interfaces. They don't have to do a checkout on the command line, then come back into the design tool and do a refresh and start editing the objects. This way it's all integrated into the design tool. So as they do their checkouts, it gives them the right access that is required to work on it as well. So the integration definitely helps because it makes the barrier to entry a lot simpler here. So towards the end and conclusion, what are the key takeaways that I would like to point out in the webinar is that, the system having an integration of the data management tool with the design tools, it helps the productivity of the engineer. It gets them to work inside one environment instead of moving around from multiple tools. Having a system that automatically synchronizes your data around the world ensures that no one is going to be working off of bad revisions or stale revisions of the data. So the data is properly getting synchronized and the users at the remote site have access to the content that they should be working on. The tagging methodology, what we discussed today were just a few examples. I have seen customers use variations of those. I have seen customers implement their own flows and their own tagging methodology. But having some methodology of how you promote the data is important because once it's embedded into the design flow, it just makes handoffs a lot more smoother. The reason we need storage solutions to be built into the data management system is important. We know, again, these chips are not getting smaller, they're not getting simpler. So storage is going to play a very important part in how projects get managed. And if it's built in, it reduces the overload and the overhead on the systems. So this way, you don't need a lot of disk access because having links to cache and sparse populate help address that. And you also don't have to constantly work with IT teams to increase the disk allocations as well. We know IP reuse is a reality. It's a trend. It's not. It started off with just complex projects using it, but I see a lot of design teams, a lot of companies taking advantage of reusing design blocks. And so we know that's a reality regardless of the type of design it is and the size of team. So traceability really needs to be at the forefront. It complements the reuse capability. It gives the ability for us to go back and run any audits that may be required as well. And version control is no longer just a simple check-in, check-out, update function. You need to think of version control as having more advanced capabilities because the challenges that we are facing in today's design environments are I guess in a more advanced stage. We have customers that need to manage variations of their designs. They may have several experiments of their designs as well. So having advanced capabilities to the basic functions is something that the DM tool also needs to address because it's no longer just a simple check-in and check-out process. So I hope these capabilities, these topics that we discussed today, kind of shows you why it is important to have conversations around these topics because we know the trend. We're seeing the trends. We're seeing a lot more complexity in designs. We're seeing a lot more reuse of data. We're seeing a lot more data getting managed as well. So we definitely see what customers are doing with their design data. And as these complexities and storage requirements keep increasing, we need to make sure we have the right solution that can help us manage all of these requests and requirements that may be coming down as we develop more advanced chips as well. So again, I'd like to take this moment and thank everyone for attending today's webinar. I hope you found this information useful. And at this point, I'd like to pass it over to Simon to see if there's any questions that have come in on the chat system, and hopefully, I'll try my best to answer those questions as well.
Thank you, Kareem. That was a great webinar. We do have a few questions that have come in the private chat. If you would like to ask a question, please feel free. Just fill it in the chat. We'll try to get through as many as we can here in the next 5 to 10 minutes. But we will get back to you offline as well if we do have too many to cover today. So Kareem, one of the ones that came in early was around chiplets. And the question is, does Keysight SOS manage data to chiplets? And if so, what are the key challenges in managing that design data?
Sure. I mean, we definitely a data management solution will manage all types of design data, including chiplets. That is, again, something we see customers asking us for is how does SOS or the data management tool help them here? The same concepts apply to chiplets as well. You will have multiple teams working on different chiplets. You will need to coordinate the design data, how the handoffs happen between certain teams, and you may have schematics and layouts and verification objects that need to get managed, and all of this needs to kind of be done seamlessly. So managing that data set is pretty much the same, but we understand that it's a different type of data that needs to get managed, and so the integrations are going to play important here. The challenges, as I mentioned, that we see is, a data consistency, version control, collaborating on the objects, and even protection of IPs that are there, because, these are different chips kind of getting put together. So, they will have different IPs and different content. So the challenge is really going to be in how we provide these protections and collaborations on chiplets.
Thanks, Kareem. Another question here is, what are some of the unique challenges that you see with managing design data for AI designs compared to traditional ICs?
AI design is something that we see a lot of companies, some, I guess, new advanced companies looking at as well. So there's a lot more data set that is involved in AI. We see, of course, the hardware data set that needs to get managed. We see algorithms that are being maintained, software code as well. So there is a lot more data that's getting managed for AI chips. So I think that's probably the biggest challenge we see when we look into the AI types of chip designs.
Okay. Another one here is, does Keysight Data Management support geofencing and security access restrictions for IP and data?
Yes, so there are, as I mentioned, access controls and protecting the IP content and even the design data content is important. So access controls is built right into the tool. You can select any objects and say which teams and which groups would have read access to it. So this way, only certain data shows up in their work areas. And also you can protect it with which groups or engineers would have write access to it. So if they can modify it, do they actually have the permissions to modify it as well? with the concept of geofencing or protecting the data as they're being shared with across sites, that is also something that the tool has built in. So if there's data that shouldn't be shared to a certain location, that can be protected as well. So we can ensure that only certain remote sites that are working on the same project but shouldn't look at certain content within that project, that data never even shows up at those remote sites. So protection of IP, protection of data is built into the tool as well.
Great. Another question here is, can you also manage verification and test data alongside the design data for lifecycle traceability to meet standards like ISO 26262 for functional safety?
Yes, we do have customers doing that, and that's depending on the type of designs that they're working on, all of the traceability is crucial and important here. So the data, it doesn't matter to the system. It could be any type of data sets. It could be binary files, text files, large amount of object sets. We can basically manage it and keep track of it with the design data that is also being managed in that project.
Okay. Another one that came in just recently here. As labels are used to stage data across groups, it makes sense that such labels are applied or used only by the responsible groups. Does SOS offer ACL on labels? And also the same data might apply to different, might be labeled by different groups for different purposes.
Sure. So I think I may have to dig a little deeper on that question, but the idea of labels is to help us pass data along, or kind of label it saying that this is my golden version or verified version. So if we are trying to protect who can assign these labels, then SOS has an ability to define certain roles for certain engineers. So only those engineers would be able to run these functions. So tagging is a function, and we can define it down to only a certain group of individuals that can run those type of operations. If we need to narrow it down to individuals and objects, and if they can assign tags to those objects that they maintain, then that can be done as well. And we can discuss, the process and the implementation of how that can be done, because it would be a combination of access controls and taking advantage of triggers.
Okay, and so another one, a follow-up one has come in for chiplets. Can the tool help in tracking dependencies between different chiplets?
Yes, because again, the data management tool, as we mentioned, there is the ability to reference and reuse objects, and so we can track dependencies that way. And sometimes dependencies are also ensuring kind of the various components that are being used. So that is also done through the referencing and reuse aspect as well. So once we establish what objects are being referenced and so forth, we can track its various dependencies, because they may be a single object that you're referencing, but there may be multiple components to that object. So we need to make sure that it's not just bringing that one object; it's bringing all the dependencies that go with it.
Okay. I think we have time maybe for two more questions here. How can data management tools aid in maintaining data consistency across hybrid cloud environments?
So having a tool like SOS there, we're basically making sure that the cache is always in sync with what's there in the repository when it comes to the revisions that are needed. Because the metadata is there, we're able to kind of make sure that the users are looking at the versions that they should be accessing, and therefore, um, working on the cloud is as if you're working on an on-prem environment. So the repository um, is in sync with the remote cloud cache that you have. Any changes that or any updates or tagging that you may be doing to these objects after certain jobs have been run, they're all essentially being maintained in the repository. So the data is also getting, sent back to the repository. So the users that are working locally in that environment also see what changes are happening to that object as well. So that's the tool is managing the the synchronicity or the synchronizing of data across these sites. So it's not something that you would do anything differently. I think you would just let the cache and the repository manage that communication.
Okay. I think we're pretty much up here on the hour, but we'll ask this final question that came in as we started this. How do you compare with competitors?
It depends on who the competitor is. It's a question that can take us sometimes hours to discuss. But I think if you look at the competitors that are out there today, I think the way we handle our data storage, the way we handle our work areas with symbolic links and different styles of working, different complexities in the work area models, um, that definitely gives us a unique edge over the competitors that are there. The integrations that we have today, I think, is far superior than any of our competitors have, because we see a trend that we are sometimes seeing, that we see occasionally, and actually it's something that is getting more frequent, is customers moving between vendors and companies getting acquired where multiple vendors are involved. So having a solution that's integrated with so many different design tools definitely gives us another edge over the competitors. Um, Now, there's a lot more details, of course, that we can dive into, the way referencing and reusing is done, the way the traceability reports are there. I know these were the talking points of today's agenda, but it's honestly, as we get into the details, you can see that all of these functionalities give us an edge over the competitors, and the way we've implemented them, I think, is definitely unique in the way some of these functionalities have been implemented.
Great. Thanks so much, Kareem. I think we're out of time here, but with some of these other questions, we will get back to you offline to those who asked them. But thank you very much, everyone, for your time today. This will be available to you on demand, the recording. So look out for an email, a follow-on email that'll come shortly. Provide you with a link to that if you want to go back and recap anything that Kareem took you through. But again, thank you very much from Keysight, and we appreciate your time. Have a great day.
Thank you, everyone.